time at the end for questions. But I like to have conversations too. So, if anyone has any questions, feel free to put it in the chat, raise your hand, message that you have a question, and I don't mind getting into it through the middle of the presentation. But with that, I'll go ahead and kick it off here. So you're kind of have to give me an intro, but I'll go ahead and do one myself just to make sure we're clear about who we're talking to. So I'm Arias Kamani. Let's start with just my background. So unlike, I would say, a lot of data scientists I see today coming from more technical backgrounds, although they do come from a variety of different backgrounds, I find. My background was in economics. And in economics, there was this wonderful field of study that I fell in love with called econometrics, which is essentially machine learning and statistics for economic problems. And I sort of fell in love with that, and I kept sort of following it. And this wonderful field that kind of combined economic theory with statistical modeling, and now more relatively into this world, today's age, machine learning, as well as like how these models can explain the world and what we can do with that information. That was like my thing, and it kind of gave me a natural lead into data science. As mentioned, I'm a director of global data science at Visa. I don't think Visa needs an introduction. We're the largest credit card network in the world. And just to be very clear about something, so folks ask me like, hey, what's with my interest rate on a credit card? Why is it? We don't handle any of it. All we do is provide the technology so that when you go swipe that piece of plastic or tap that piece of plastic or use the number for a digital transaction, we can communicate with all the banks, the merchants, and you to facilitate the transfer of funds. VisaNet, I'll get more into it, the network can handle about 65,000 transaction messages per second, largest in the world. I'm sure everyone here maybe very likely has a Visa card. I'm also, on the side, I'm also a co-founder and head of content for HE Data Science. We produce an online data science, engineering, and analytics platform for folks to assess their data science skills or analytics or engineering skills. With that said, let's go right into. Oh, I'm sorry, I have even more of my narcissistic self to talk about. 10 years experience in data science and management. My first predictive model I remember was built way back in 2009. I can get more into it later, it's kind of relevant to somewhere in my slide. Touched a lot of different industries, healthcare, manufacturing, food service, logistics, cruise lines. Before Visa, I worked at Royal Caribbean here in Miami, where I'm based out of. Just a few fun facts about myself. I'm a PC gamer. I really love it. I do enjoy karaoke. I won't be singing here tonight. That's not the purpose of this. And the one thing I do miss about COVID, I guess what COVID kind of took away from me, what I couldn't do anymore because I can't go outside, is compliments on my outfits. As you can tell from the picture, I guess I take my outfits very seriously. So anyway.
Don't worry. We will give you lots of compliments though.
Okay, hopefully not at my outfit today. I'm hopefully going to get some comments on data science, hopefully. So we'll see. But thank you, I appreciate it. Okay, let's get into what we're going to talk about. So, okay, as discussed, we're going to first go through some AI and data science, techniques or topics as it relates to digital payments. I'm also going to give you sort of an overview of the digital payments ecosystem. I'm going to give you at least what I believe, my own opinion, and we can maybe have some good discussion on this if we'd like, on some emerging tech and topics within data science and AI, what I see and also don't see coming. And I thought, as students, maybe we could also have a discussion on what are some advice, at least maybe I can give you from my perspective, that hopefully could be beneficial to you all. And then we'll do some Q&A at the end. I'm just going to do a quick check. Is anyone having any issues, problems? Everyone okay? Okay, I'm assuming nobody's going to chat anything. We're good, and we'll keep going. Okay. Topic one. Let's talk about data science and AI in the world of digital payments. Before we go there, let me at least give you an overview of the ecosystem, this digital payment ecosystem, okay? In the beginning of the economic world, you had two actors, right? You had a consumer or cardholder, let's say consumer for now. You have a consumer and cardholder and a merchant, a demander, a supplier, a buyer, and a seller, okay? Now, through most of human history, the idea was that you'd have to, if you wanted something, you had to go to the merchant and either, physically, maybe even, call them on the phone, whatever, or even now online, but you had to exchange some sort of hard currency, okay? But now with credit cards, these transactions, you don't need hard cash, and more importantly, there's this whole facilitation of the movement of funds from your account to the merchant's account very quickly. So let's just see how that looks like and where Visa plays a part. So think about when you tap that plastic or when you make a payment online, okay? You're sending first your card information to what's called the issuing bank. That is the bank that has your account and gave you that card. Okay, so your Bank of America's, your Wells Fargo's, or you have a credit card in cases of, say, Amex and Discover, who are both, they make the accounts as well as have the card network, whatever. So your information first goes to the issuer. That issuer says, hey, this person does have the funds. And if the funds are good and they verify your identity is correct, your money from your account gets sent to the acquiring bank. That is the merchant's bank. That's the bank where the merchant's account is. And then that acquirer says, hey, guess what? I went ahead and everything's done. There's a message sent back to that terminal, or their system says, hey, everything's good. You have the trust and everything's verified for you to hand that physical product or service to the cardholder. And of course, you get your shopping bag, your product, or whatever it is. Where Visa plays in on this is we're kind of in the middle. We have the network, VisaNet, that facilitates all this transmission of data among these four parties: cardholder, issuing bank, acquiring bank, and merchant. And that's where Visa plays part, the technology, in addition to all the other cardholders that we know of, MasterCard, Discover, and Amex. But again, I work for Visa, so I'm going to push them really hard, and they're the best. So, any quick questions on the ecosystem? You're free to chat. It's all okay with me.
Arya, we have decided that after your presentation, participants will ask you the question. Yeah.
Okay, sounds good. So I won't ask them. Okay, let's keep going. Okay, now you know about the ecosystem. Let's talk about where AI and data science can help play a role here. This is probably one of the most obvious ones, but it's also arguably the most important one. We know that every day there's billions of transactions. So I said at the beginning that the Visa network can do 65,000 transaction messages per second. And I kind of did the math, and if you just do it for a single day, that's if I remember correctly, 5.6 billion transaction messages being handled every day by the network. Within all of that, there are legitimate transactions and transactions that could be flagged or identified as fraudulent. And it's not, to do this at scale, there's machine learning and AI in the background that is attempting to facilitate all that, from historical data as well as at-time data. Just to give you an idea of what's the scope we're dealing with, this December 2020 Nielsen report, they follow a lot of these credit card market news. 28.6 or 7 billion. That's the total amount of losses attributed to fraud that your merchants, issuers, remember that's the bank where your account is, acquirers, that's the bank where the merchant's account is, that's a total amount of dollars lost to fraud. So, for example, if you get an alert about something where, hey, did you really make this purchase? And you say, no, I didn't. The bank is kind enough to send you your money back. but that's a loss to them, right? They're trying to keep you happy, but it is a loss. That's a fraudulent transaction loss that they eat. So that amount just in 2019, about $28.7 billion. And it's only going to get, it's forecasted to continue to grow. Roughly 7 cents of every $100 is a fraudulent transaction, and 65. And you just look at the entire universe of fraud, 65% of all that fraud is what's called happens in card not present, or basically online digital payments. Like when you go to like try to buy from Amazon or another merchant. So that's the universe of fraud. Now let's talk about what Visa does to attack that problem. Here's a link or excerpt to an article published in July of 2020. And this is an interview with Melissa McSherry. She's an SVP of Global Data Security Products. And you can see here that through the use of AI, it's estimated that Visa is able to save or prevent $25 billion worth of fraud. So we're almost cutting that fraud loss in half, because we're able to detect like, hey, this is fraudulent, don't let this transaction go through. And you can read a little bit, I sent a link to an article, but if you're interested in what type of AI is used, there's a small snippet in the middle that kind of gets into that. This particular one has like a combination of recurrent neural networks and gradient boosted trees. At least we've got a little information, we're not gonna give away all of it, but a little information of some of the machine learning being used to power this. What's also interesting is the very last paragraph that talks about the implementation of this, because if you remember, there has to be like 5.6 billion transactions handled every day. And these models have to run in milliseconds worth of time. Sometimes they don't run directly on VisaNet, they might run on a system outside of VisaNet as well. So we kind of place a model outside the system, so the transactions, the scoring of these models doesn't take very long. So there's an engineering play here as well.
So I have a question. Can I have a quick question?
Okay, sure. Quick question. One second.
Oh, sorry. So my quick question is that, like, how accurate the machine learning try to improve the fraud detection?
So I don't have a number off the top of my head, and I do not want to give you anything that's wrong. I'll make an effort to try to find that information. I can let Hardik know, and he can let you know. How about that? That sound good?
Okay, thank you.
Good question.
Yeah, all participants, you have to ask a question after his presentation finish, because we want to finish presentation first and then question answer session. So just keep these things in your mind.
Okay, thank you. Sorry.
Yeah, it's
just so interesting. Like I really like the topic. I really like,
Great. I'm happy about that. I'm happy about that, and probably my fault too, because I offered to answer questions, but it's okay. We'll get time. Let's talk about another way. Okay, so fraud. Okay, awesome. Let's talk about another way. So there's lots of things you can buy out there in the marketplace, right? Like I found some icons on a bunch. Okay, so there's lots of things you can buy, and you're one of billions. Well, there's 3 billion cards in the Visa network alone. So you're one of billions of consumers or cardholders out there shopping, right? Now, data is being collected, obviously. We like any good company that is out there, Visa has data, and we want to use this data to provide you the best services and the best products. So there's this concept of cardholder value optimization. So let's just say we have 1 billion or some number of cards, and I have all these features saying, hey, what are you buying? All these features, thousands, maybe potentially, tens of hundreds of thousands. I have all these features. I say, hey, I want to try to see if I can take your shopping patterns and maybe identify a segment that you belong to. Maybe based on your shopping behavior, I say, hey, can I group your behaviors into what type of, and maybe I can get a bit of information on what is relevant to you as a cardholder. So you guys know this already, right? Hopefully you're thinking in your head, okay, lots of features, that's a dimension reduction, I can use PCA autoencoder, maybe a manifold technique, and then once I have these reduced sets, I can do some k-means or density-based scanning to cluster. Awesome. From that clustering though, you have these unique personas and segments, and with that, bam, each one of those can get a card. a specific card with benefits that's relevant to that consumer, that card holder, and therefore entices the card or maybe upgrade to another one. For example, you guys might know, you might see ads, hey, some cards offer cashback on everyday purchases or points redeemed. So we also have, there's also student cards out there, or cards with, let's say, entry, or let's say you're emerging, your credit's starting to emerge, so there's cards that focus on that, on building your credit. There's also for more affluent folks, for their diners and travelers, we have cards that reward you more on those. Your Chase Freedom and Sapphires, for example, which is a Visa branded card with JP Morgan Chase. So again, but the main point is, hey, the data science AI is used to analyze this data, create these unique, these personas, and says, hey, for each one of these personas, we want to optimize the value we bring to you. Any questions? We'll get it to the end. Okay, I'll breeze through this. This is just my own opinion, but we hopefully as wonderful students, you're forming your own, you're looking at the world of AI and you're thinking, hey, what's new, what's coming, what's out there, what should I yes or no get concerned about? This is just my own opinion, but we can have a discussion on this afterwards. Here's what I see here or coming soon, right? One is this world of more accessible AI capabilities, and this is being pushed, I'd say, not just by open source, but by proprietary technologies as well. You folks may have heard, for example, of GPT-3, which is this somewhat scary, but also state-of-the-art natural language processing tool. Well, I guess tool is the wrong word, but it's an NLP framework that is very, very, very almost scary good at mimicking human responses. In fact, I think the creators of it around GPT version 2 came out and says as much, that it's a little scary how good this thing is. And as this technology becomes more, it's not just open source, but as more people take it, package it, and easier to use, that is, just one example. We also have this world of auto machine learning, where and what I call citizen data scientists. These terms have been around for a while, but this prevalence of, hey, you don't need to be a data scientist to do machine learning. Take this program, just force feed it your data. This thing will auto ML everything for you. Typically, they're very brute force. If they run every model that you can imagine and then spit out what works. But it does enable a lot of folks to do data science without necessarily being data scientists. We also have out-of-the-box solutions. So what I mean by that is companies are selling these ready-made packages. Like, hey, if you want to do facial recognition, here, we'll sell it to you. We'll make it a part of our suite of services. You want to train a chatbot? You don't need all the data. We already have it available. We'll sell it to you as part of our suite of services. Explainable and ethical AI. Back in 2016, I believe, there was a wonderful paper on something called SHAP scores, which is Shapley additive, I forget the rest, I apologize, but SHAP scores is this really cool thing, model agnostic way to explain how and why machine learning models make decisions, how one feature actually impacts the decision of the machine learning model. It's not like feature importance, it goes beyond that. It's actually saying globally and to the record, hey, for any model, I can estimate, given the foundations of the math behind it, why it made this decision. So that happened in 2016 when I got first excited about it. I didn't hear a lot in industry, but now I'm hearing about it a lot more. Not just in industry, but on Stack Overflow and all those other forums. So it's becoming much more relevant. Things like Lime also becoming more relevant. Just ways to explain why AI makes a decision is now very relevant. Some of that comes from regulations. Some of that comes from, I think, our inherent desire to tackle bias in AI. There have been lots of cases, I think, where AI is applied, and because the data itself is biased, the models themselves are biased to certain decisions, and now we want to explain and account for that. And I think more and more you're going to see, as people become more aware of how much AI, machine learning, data science is sort of part of their lives, they will in turn demand more ethical use of AI. And I think that part of that is going to be, hey, I want to know why this AI made this decision about me. Lastly, I think there's some cool advances in computer advances. So one is quantum computing. I know I am not an expert in quantum computing, but I have been reading about it, keeping up with it. I do think in like from what I'm reading, and there was actually at Visa, there was a professor actually came in and spoke on this topic in our innovation lab once, and I think it's super cool. He said I think in 5 to 10 years is when quantum computing is really going to take off and has to be leveraged in industry, not for the least of things, security concerns. Apparently, quantum computing can break through all these binary security methods very quickly, and so we got to catch up with that. There's also this thing like, you got this trend of advancements in these very cool fast machines and quantum computers and new GPUs and all that stuff, but there's also this move to try to do more with what we have now. I believe not too long ago, I think last week, there's some research out of Rice University where they created an efficient deep learning algo that can just run on a CPU alone, and it can train like 15 times faster than even a GPU. So doing more with what we have is also going to be a big trend. And then also doing AI on the edge. I mean, this is not a new topic, but it's just going to happen more and more. And what I mean by that is you're going to see AI, like data isn't going to be sent back to a central data warehouse to do all the modeling. You're going to have mini models kind of everywhere in like your phone, which is, we have facial recognition on the phone today. You'll have, just models running in many more devices outside of a centralized system. So anyway, those are just trends I see. Some are not new, but in some cases they will continue. What I don't see coming, and I'm only putting this part because I just had a conversation about these two things not too long ago with another colleague of mine, so just made me think like, hey, maybe this would be relevant to talk about. One is this concept of an AI overlord, like AI is going to come and sort of take over, and we're going to be slaves to AI like very, very soon because things are moving so fast. We got to remember, I mean, I know there's folks that are in this camp of saying, yes, it is very possible and it'll happen soon. I'm more of the camp of I don't think it'll happen soon. Maybe there's the potential for it to happen, many years. But what I see, I see models nowadays where if you rotate a picture, it can fool the AI into thinking like a bus is a plane or something, just by rotating a picture. So we're not at the cognitive capability of AI just yet to do this sort of thing. I think what we need to be more aware of, what I see more is AI kind of slowly creeping into our lives where we might not expect it to be. And those are the sort of things that maybe we need to watch out for. Like, is our government, our companies using our AI ethically? Obviously, Visa, we strive to do so. But I think, again, as people become more aware of this thing, at least I say this is what people should be the most aware of, not this AI overlord concept. And then lastly, I talk about AutoML, and there might be this natural inclination among data scientists to say, hey, can AutoML replace me? Because I'm building these algos that can do all these cool things, am I kind of digging my own grave here? And what I see is AutoML, going back to the citizen data science concept, it's more about it's going to handle all these low-hanging fruit problems for you, maybe some semi-complex ones, but now data scientists are free, they're augmented now to work on much more complex problems. So I see the world of AutoML increasing the need for data scientists, because now you don't need data scientists to handle, I would say, the relatively simpler tasks that maybe some of these AutoML ones can handle on their own. They can now move on to more complicated tasks. So, okay. Hopefully this will also be very beneficial. I thought it would be good as oncoming students, maybe you would like some advice that maybe I can give you, and hopefully that would help you in the world. Now, I said I'm a gamer, and I might be dating myself, and I try to look for a good quote on advice to be inspirational. I couldn't find one, so I remember this from my boyhood days. Advice is free, but making use of it costs much more. And what I kind of take away from that is, you can get advice from anybody. I'm giving you some advice, but I can only give you advice that worked for me. And I think, I'm going to give you what advice that I know that I think is helpful, but you'll eventually have to find your own way in the world and think about what advice works for you. But I would hope that at least what I can give you is a good starting point. That at least started me right. So one thing I want to talk about as you start your career is what I like to call the concept of depth and complement. So when I look at data science resumes, you might have heard the term a mile wide and an inch deep. And what that kind of means is I see a little sprinkling of experience. Every buzzword you can think of, I look on resumes that I've done all these different models, all these different texts, all of that. And I said, okay, are you really, really good at any one of them? Or when I test their abilities, it's just on any one of these data science candidates, it's very on the surface. What I found to be a much better, what has worked for me, and what I found to be a much better indicator of a candidate's skill sets is try being really good at a few things. Show that you can be really, really good, or you can understand a few topics really well. And that does a few things. One, at least it shows that you're an expert at least something, right? You're good at something and you can take that somewhere. And it shows that you have the capability and vigor to really invest yourself into something and show that you have the capability to be an expert, or as close as you can be. A sort of a contrary thing to that is being mindful of taking skills where you might sort of be just okay in and learn how to leverage them in combination to create something to sort of lead to success. I personally don't think I'm that good at any one skill. I probably overall, in my estimation of my own abilities, maybe I'm just too hard on myself, but I'm probably like a B- B+ person in modeling and presenting. For my charisma, at least I'm not making people run away. Okay, fine. But what I find that's useful is I can take all these things that I'm kind of okay in and know, hey, if I combine them in this way, I can deliver something, complete and objective, resonate with an audience. I can be more successful if I take things that I'm kind of okay in, but learn how to combine them, and then it's a much easier path to success for me. Being mindful of storytelling and visuals, and I know I'm kind of running out of time, we're almost done here. I used to joke when I first started in management that now I'm doing more PowerPoint than Python. I joke, but it was true. There's a certain inflection point where your skills as a storyteller, as a visualist, are going to become much more important than the code as you sort of go up in seniority. And I would say it's very important to, as you move on, maybe we're not all inherent visualists, but it might be good to understand at least how to develop, just enough PowerPoint to develop a good presentation, and also how to cater and connect with your audience. I'll give you an anecdotal example. I actually just shared the story on another university presentation. My first job out of grad school, I worked for a healthcare consulting company, and I won't get into it, but I was in a data science project presenting to a client. And I found this insight that I thought was going to blow their mind away. I mean, at least internally, we all thought it would. It looked very, very promising, was going to save them a lot of money. Basically, I was telling them, hey, I know you're doing X, but you really need to stop doing X because you're wasting a lot of money, and you need to do Y, and the data proves it here. Get blown away. And I thought I had to keep selling this information. What I didn't appreciate was there was one gentleman in the room who actually was the responsible for saying the company should do X. And I'm in there hammering home why you need to stop doing X and do Y. And after the presentation, my boss kind of takes me aside and says, listen, you made your point once, that was great, but after that, I really wanted to kick you under the chair because you were just making things kind of uncomfortable for one of the stakeholders. So again, know your audience, know who you're catering to. You're all trying to do data science and AI, you're aspiring to data science and AI. Don't think the first job you need to get has to be a data science or AI position for you to be successful. There are BI positions out there, strategic or I would say strategic analytic positions out there, engineering positions out there, analytics positions out there, visualization positions out there. If you really want to go for it right at the beginning, awesome. but it doesn't have to be that way. You could start in any one of these amazing related fields and find your way, I think, to something wonderful down the line. I, for example, started out after grad school as an IT project manager of all things. But I was very good at math. If you know the whole classic data science diagram, you need math, engineering or hacking capabilities, whatever they call it, and business. And I was really good at math and business, but I was really lacking in tech. And this random job that I did really helped me build up my tech, and it made me a much better data scientist moving forward when I finally decided to make it like my thing. With that, I am all out of oxygen. So there's a link to my LinkedIn. I'm very, very open. If anyone wants to connect with me, talk to me with advice, ask questions, wherever you want. I'm very happy to do so. Again, I never had someone like this helping me learn stuff as I went on. So if anything I can do to help, I'm very happy to. And now, I guess we'll do either, Q&A, or you can, if I wasn't good enough, you can tell me to go away. But that's it. Thank you so much. I guess, do we have any questions from this wonderful group of people? You know what? I see raised hands. Okay, so Wesley Martins, why don't you go first, since I just see your raised hand up there.
Hi there. I'm Dr. Martins. My credential is Wesley Martins from UHV. I'm a colleague from Dr. Gahel. Thank you for your presentation. It's really inspired. I just wanted to develop a little bit better, because it's very inspiring at the level of the college. Have someone that already passed through this experience and go to the market. And we know that the market still value three essential things: credential, life expertise, and recommendations.
Yep.
But when you are green and go to the market, you might only rely on your credentials, your college credentials, and you might not having a very suitable networking to provide a recommendation. Then you probably might not have the far life experience on the field to provide the future employees. But it's really important that you sell yourself as